All right, Eric went into grave detail about the information model, highlighting many of the subsystems of the capabilities of the utility network. And then, of course, we'll have specific presentations for each of those topics that will get into nice demos, talk about the high-level story, show you the technical details of what's going on when using those parts of the system. And I'm going to now cover, just for about 10 minutes, the data model, right? So Eric was focused on the, the information model, now the data model side. He touched upon it a little bit, but the important thing about the utility network, we're still working within a geodatabase, right? We're leveraging all the capabilities of the geodatabase that we've had for nearly 20 years. It's just a controller data set. It's based, again, what we highlighted on a collection of domain networks. Now, what Eric showed on the one slide is, as each domain network is added to a utility network, 5 feature classes are created. And those are what you interact with via the layers in the applications. And then we have the one structure network. And again, remember, these are just a feature data set, feature classes. Therefore, we can have feature-linked annotation, we can have relationships, domains, all the other behaviors of a geodatabase. So if I can escape out of this, actually look in Pro, and here I have my ArcGIS Pro session. I'm in the catalog pane here on the right side. Nice. You're not seeing that. There we go. The catalog pane, and you can see that I've got a connection to my geodatabase. So essentially, I'm working in client server. I'm the administrator of, or the owner of, this feature data set of my utility network. And what happens when we create a utility network, you must have an existing feature data set, and you must have a service territory or a polygon feature class as input when creating the utility network. And then as domain networks are added, these 5 additional classes are added to the feature data set. So essentially, I've created a domain network called electric distribution. So I have an assembly feature class, I have a device feature class, a junction, and I have a distribution line, and then I have a subnetwork line class representing those aggregated subnetwork features. Here again, you can see the actual utility network itself. Same thing that you've seen previously with the geometric network or topologies or parcel fabrics, right? They all have this controller data set behavior, and we're just continuing with that model. So then when I want to add this data to the map, right, I can always just directly add the utility network to the map. I've already done that here. But what I want to highlight now is if we actually go to the utility network layer in the map, you will see that it has all the specific error feature classes. Right? We have a point error, a line error, polygon errors, and dirty areas. You don't see those specific classes inside the feature data set. Right? These are all the classes and tables that make up the topology, the associations, the error features. They're all hidden from you, but are important pieces that make up the capabilities of the utility network. And also, if we see on the right side, you can see how I have relationships between tables. Even I have structure attachments, geodatabase attachments to my structure feature class. So if I want to take pictures of my poles or my vaults and so forth, I can attach them. So nothing new there. And you can see also in the map on the left side in the table of content, you can see here are those relationship tables, right? Still just a table. Same story that we've been telling for 15 plus years. Now, if we actually look at the properties of the utility network, we can go in here, right-click, look at our network properties. This brings up all the information about the utility network, all how it's been, when it was created, who's the owner, how it's been configured. And throughout all the other presentations that will be coming up, they'll go into very specific details about these properties, so I'm not going to repeat anything there. But in essence, one of the things that we can see when a utility network was created. This was something our users have been asking for is, can we do better with time-stamping information about the metadata as we configure our utility network? So you'll see this among many of the properties, a timestamp, so the administrator knows when it was added. This is important, so as you build out your utility network, change rules, add more behaviors, you'll understand historically when that change event took place. Tell you information about what release of Pro created it, when it was last modified. Last modified in the sense of its configuration, not when it was edited. Again, this is important because organizations typically have multiple representations of their data, right? They've got data sets configured in a sandbox for prototyping, they've got them in test environments, and then they have them in actual production. Now, some of the things about the network topology, we report all the errors and so forth. Dave will go into this topic specifically. But what I wanted to highlight again was about more the data model and what happens with these specific domain networks. As we said, there is always one structure network always present in every utility network. Here are those three classes that we talked about. The structure has junctions, lines, and boundaries. Well, no surprise, that's a point, line, polygon. Right? We're constraining the model for you to only work with three specific classes. But how does this make it extensible if I'm constrained to a single class? Well, this was a takeaway from what we learned with the geometric network. When we built that model of the geodatabase, we said, hey, you'll have this very extensible model where you can build out and add classes and then define all the rules. And before we knew it, we had some users who may only had 5 or 6 classes to represent the features in their geometric network. Then we saw models of up to 40 classes, and that really impacted the performance and usability of the system. So how we solve this problem by limiting it to one feature class? Well, we're using that subtype, that asset group that we talked about. So again, we didn't, as we talk about the utility network, we didn't want to keep on saying, well, the subtype field. Well, everybody's like, well, what's a subtype field? Because in the geodatabase, you can call your subtype field anything you want. So we standardized on the naming convention asset group. And that asset group then becomes the representation of what those features represent. Is it a cabinet? Is it this is for the structure junction. Are they handholds, manholes? Is it a pad, a pedestal, and so forth? So now you can start to see how we had feature classes before these become essentially these asset group representations, which will still be layers in our application. And then that discriminator field, which is called asset type. That's where we can get into the very specific details of what these groupings represent, right? So again, we're modeling the asset type field with a geodatabase domain, and that domain is the definition of what describes that specific group and allows us to create the rules and the configuration of our model at the type level. That's very important. And again, others will talk about how these association roles work and so forth. So that, for example, is the structure junction and the structure network. If we dig a little bit into what a domain network has, again, we see the properties of when it was created, its alias name, its subnetwork definitions I'll talk about at the end of the day. We get into tiers. But again, we can see what's important here. Here are those 4 feature classes that were created that allow you to model the features that make up the properties of a domain network. We dig into the electric distribution device. What's important about devices, it's a device or a real-world asset that the organization is tracking that manages the flow of the commodity that you're modeling. Be it electric, you have things like breakers, elbows, fuses, switches, transformers. In a pressure network, you can have valves, regulator stations, and so forth. So that's essentially what I wanted to highlight in this section. And others in the team will be able to dig deeper through their presentations into how these are used and modeled. So as I hand it over to our solutions team, any questions? Right. The question is if I need to integrate the other type of feature classes, be it easements or land base, or I'm trying to think of the other non-features related to the utility network. Do they need to be in the same geodatabase? The answer is no. It's all about how you're going to configure and make those data sets available through services. But what's important is when it comes down to the editing workflows. And I'll probably loop back in tomorrow's session when we talk about the versioning model and why those dependencies may pull in those business requirements. So let's get back. Yep. Yeah, another good question. Exactly. So the question is, could there also be dependencies between classes or layers when we start leveraging attribute rules? For the first release of attribute rules, the behavior of those arcade expressions are limited at the feature or the row level that's being modified at the time of the transaction. A future release will be able to support layer-on-layer capabilities, what Eric was talking about, to derive a feature set. So if I want, as I placed a feature, a point feature, spatially intersect a polygon of another feature class. Well, yes, in those cases, that data would have to reside in the same physical geodatabase, but we're also looking at ways to be able to pull that behavior up out of the geodatabase level, up in the application tier. So possibly maybe USGS is serving up a soils layer off of their feature service and their map services. Well, that's present in the application tier. It's the application that knows to do the point and polygon to be able to assign the soil acidity levels and so forth. All right, over to Mike.